All right, good afternoon, everyone. First of all, welcome to NET214-S session here on day 4 of AWS reInvent 2019. My name is Azim Salman. I'm a principal engineer architect from Cisco Systems, and I have a colleague, Mari Kulkarni. She's a senior product manager. We are both from IBNG, which is Intent-Based Network Group from Cisco Systems. Today, what we're going to talk about is how we can help you to go to the journey of hybrid cloud. And we're going to talk about all the key components, use cases, and architecture. With that, I will allow Mari to get started.
Thanks, Azim. Good afternoon, everybody. Welcome to day 4 of reInvent, and hope you have been having a good time so far. Yeah? So before I go deeper into the topic, let's just go over the agenda. We are first going to talk about the challenges that we see customers facing in this hybrid cloud world. We are then going to talk about the frameworks that you should think about while solving these challenges, and what are the key architectures which are used to solve these challenges. We'll follow it up with a demo of the solution, and then with a Q&A, and that's pretty much it for the session today. So I want to talk about first the hybrid cloud challenges, set some context in terms of what's happening for your business. What are the key drivers for your business which is making the hybrid cloud happen, right? So whether you are a banking company who is trying to survive in this disruptive market of financial technology, or you are a retail company who wants to innovate more, having more interactions with your customers, or you are a university just working on the most cutting-edge technologies, you are trying to constantly innovate your applications. You're trying to constantly build new digital interactions with your customers. And while you are doing that, you need to ensure that the infrastructure on which these next-gen applications are based upon, this infrastructure is an agile and elastic infrastructure. As you heard the gentleman before us, what he was speaking about, building the next-gen applications and building cloud-native applications is the key to success in this hybrid cloud world. So in a nutshell, you need infrastructure which is capable of delivering on these next-gen applications. At the same time, if you're not a web company, like you are an enterprise company who has been in existence since more than 10 years, you will have a mix of older gen applications and the new gen applications which you are building. So all the old technologies or the current technologies which you have already been using in your on-prem data center, they still need to exist in tandem with the new applications that you are building. And because of this, you need to have the flexibility in your infrastructure so that the infrastructure is you are able to give the best of breed infrastructure for your applications. And those applications can be spread anywhere between your on-prem or the cloud data centers. And then if you wear the hat of the CXO of your company, cost optimization is a must in this world. So you need to have a mix of predictive CapEx-based cost models or an ongoing OpEx-based model. And that flexibility is required for your company, for your business, in order to thrive your business in this cloud-native world or in this hybrid cloud world. So overall, across the board, because of the various cost structures between on-prem and cloud sites, we are seeing a lot of enterprise customers adopt a hybrid cloud model. Now let's see what the industry is talking about in terms of hybrid cloud adoption. IDC Cloud Pulse is an industry-wide survey which is conducted every quarter, and they have some interesting results in the recent survey that they conducted. So quick show of hands, how many of you have production workloads deployed in hybrid cloud today? Okay, almost 50% of the audience, I would say. Yeah, so that actually is resonating with what these guys found. 92% of the enterprise customers who were surveyed, they have some or the other kind of hybrid cloud deployment today. But only 50% of the customers who were surveyed had production workloads in cloud. And then out of those, only 32% of the customers had some kind of cloud-native applications which were built on the cloud and which are running in a cloud-native manner. So there is a lot of application restructuring happening, a lot of repurpose happening for your applications. But at the same time, there are certain key priorities that was found by the same IDC research. And the priorities for these customers, if you're an enterprise customer, is the same priority for you guys also, which is having a compliance and governance, a common compliance and governance, which is a corporate-wide compliance and governance for your applications, for your data centers. And this is not just because, the cloud has a shared responsibility model. So as an IT ops team, your IT ops teams is responsible for ensuring corporate-wide governance. Second thing is operational simplicity. So you need to ensure that any day-to-day operations that are being conducted by your teams, it is simplified in a manner such that you get really fast, you work at the speed of DevOps, basically. And then automation for driving efficiency and speed. So IDC has found that these are the key drivers. This is the current state of affairs in the industry for hybrid cloud. Now, as customers are adopting the hybrid cloud environment, we also see a lot of requirements come up for the IT ops people. So quick show of hands, how many of you are developers or DevOps team members? Okay. IT ops? Okay, so we have a mix of both. And what we see is, for the IT ops teams, there are these business requirements. Because of these business requirements, there are requirements coming up for the IT ops team to start building an automated connectivity between your on-prem sites and the cloud sites. Now, this becomes difficult because there are 10 different devices in your on-prem data center, devices at the edge location, and then within the cloud that you have to go and configure. So if you have to do this manually, not only is this going to be error-prone, but there are chances that you will take a longer time to build this interconnect. Then the second key requirement is you need to ensure that there is consistent policy and security for your application workloads as you are adopting hybrid cloud. Again, this becomes an issue typically because in your on-prem world, you have a different language that is being spoken. You are speaking Spanish. In the cloud world, you are speaking, say, English or French language. You have to do the translation between these two languages, right? You have to convert your firewall rules, your ACL rules, into your VPC security groups, into the WAF rules of your cloud firewalls. So this translation, if it is to be done manually, just imagine how long it will take your network admins to go about configuring all of these various components. And then last but not the least, your day-to-day operations. In case of any troubleshooting requirements, in case of anything which has gone wrong between your on-prem and the cloud sites, you need to have an end-to-end view of what's happening within the network. You need to have a connectivity view. You need to have a view which says, this is where there is some packet drop happening. This is where some device has gone down, some link has gone down between my on-prem to the cloud sites. So overall, these are the key requirements for your IT teams. And then there are the challenges that come along with it. I want to still stress upon these challenges a little bit more, because the key to the framework and the solution we are talking about is in you understanding these challenges. So now let's just imagine you have a single on-prem data center. You're connecting it to a single cloud region in AWS. You identify which are the VRFs, what are the network segments that you have to extend from your on-prem to the cloud sites. Once you have identified it, you go and configure your devices within the on-prem data centers with those VRFs. You go and configure the IPsec tunnels that you build for your on-prem data center to the cloud site connectivity. And then after that, you go to your edge location, configure the firewall rules, configure the BGP peering. So you need to be expert at BGP while you are doing all of these configurations. If you're a network ops, that's not a big deal for you. But if you're a cloud ops person, yes, you need to understand all the nuances of these particular protocols. And then you are configuring ACLs and security rules on the edge devices. If you have a DMZ location where there are some IDS, IPS devices which are running, at that DMZ location, you have to, again, configure all the rules before any traffic reaches the cloud or before any traffic from cloud comes to your data center. And then on the cloud side, yeah, you have to configure the networking for the cloud as well. You have to configure your VPC route tables, all the different transit gateway, and any other peering that needs to happen between the cloud and the on-prem side. When we counted the number of CLI commands which it takes to do just this connectivity between one on-prem site to one cloud site, it takes more than 1,000 CLI commands to get this done. So imagine the complexity when you want to start connecting multiple on-prem sites to multiple cloud sites. And you have to scale to different regions based on your business requirements. So the complexity is actually multiplying as you start scaling up this connectivity. And then when we are talking to our enterprise customers, we also see some patterns emerge for the application deployments. And typically, some of the patterns are around the way you are deploying your application tiers between the on-prem and the cloud sites. So suppose you are a retail company, it's the Thanksgiving and the holiday season, you are expecting a lot of traffic on your web servers, and as your IT ops teams start preparing for this holiday season, they start to build or stretch their web servers between the on-prem and the cloud sites. As they start doing that, they need to ensure that any communication policy for these web servers are also dynamically moving with these web servers as they start scaling into the cloud. Then across the board, we see enterprise customers using cloud as a disaster recovery site. In a disaster recovery site, the application deployment pattern typically is the same application stack gets replicated between your on-prem and the cloud site. And as this stack is replicated, again, the communication pattern between your typical application tiers, like the communication pattern between your web tier or the database tier, that pattern needs to be consistent because you do not want stray workloads accessing your database servers once you start scaling out into the cloud. So you need to ensure that that consistent communication pattern is maintained as you're scaling from different regions across the cloud. And then we have application developers in the room here. So we know the typical application staging environments that go with any app development lifecycle. You have a dev environment, you have a test staging environment, and you have a prod environment. Now, as you, as an application developer, as you're trying to run in this agile development environment, the last thing you will want is for somebody from your IT ops teams coming and stopping you or interfering, saying, hey, this does not apply, the security policies are not being applied, or this does not adhere to our corporate governance policies. That's the last thing you want to hear, right? But it's your security team, it's your IT ops team who is responsible to maintain that policy, who is responsible to maintain the security within these dynamic environments. And to top it off, if these workloads are trying to access any shared services or shared resources sitting in your on-prem data centers, it becomes all the more crucial for these policies to be applied. So what is happening here is, the challenge we are seeing is, as an IT ops member, you have to be on top of all the dynamic changes that are happening, and you have to work at the speed of your DevOps teams. And last but not the least, we have different operational tools which you have been traditionally using within your data centers. Now, these operational tools, even though you have different tools between your on-prem sites or your cloud sites, you still are doing actually 3 or 4 different tasks every day as part of your day-to-day operations. You typically configure, proactively do some config management, do some configuration on your networks, or if it's a bad day, you're actually doing some troubleshooting, firefighting, trying to figure out what's wrong. Or the days when everything is good, when God is happy with us. You're just monitoring. So you're in a monitoring mode, passive mode, and but across the board, the operational life cycle, if you think about it, it's still the same. You're doing these 3 tasks on an ongoing basis, but you are using different tools to do these tasks. Now, the tools between your on-prem data centers and cloud sites, they are disparate tools. So you have different tool sets that you need to learn, that you need to quickly adopt to. Your existing on-prem tools should now either get integrated with the new tools, or you need to enhance these tools to operate across this dynamic environment. And plus, obviously, there are 2 different policy domains, your on-prem policy domain and your cloud policy domain, 2 different domains. So some kind of a handshake needs to happen between these 2 domains. And that is where I want to start talking about the architecture and the use cases that have evolved for the hybrid cloud model. Now, if you attended yesterday's leadership session, we announced the partnership between AWS and Cisco on some of the key innovations that have been happening around this area. So what I want to introduce you, a lot of you might already be knowing the Application Centric Infrastructure, or ACI, which has been in existence for more than 6 years for your on-prem data centers. Now, the same technology, same solution, we are now putting on the cloud. So we are extending the same logic into the cloud world. When we started with the SDN journey almost 6 years back with Application Centric Infrastructure, or ACI, what we found is customers want this flexible and scalable infrastructure, which is not just programmable, so it has to be a programmable infrastructure, but it needs to enable application deployments. It needs to enable rapid application deployments. And for that, we built this infrastructure for our on-prem data center using declarative group-based policy model. So I want to pause here and talk about 2 key concepts and 2 key frameworks that have been used in the solution, which are important for you to understand no matter what solution you're using. So the first concept is that of declarative policy model. In a declarative policy model, you have a control system, and the control system tells your network objects or whoever are the objects running, whichever are the objects running within the entire system, what is the end goal for the system. So as an example, take an example of an air traffic control system within your airports. So how many of you would want a dumb pilot flying your flight? A pilot who has to go back to the air traffic control system to ask what needs to be done next, what if there is any dynamic change happening in the weather, what should be done next? Nobody would want that, right? So in a similar manner, the air traffic control system is just telling the pilot, this is your source, this is your destination, and go fly the flight, go do your job, but use these set of rules and use these set of source and destination for doing your job. Now, it is on the intelligent and independent pilot to make sure that they adjust the airspeed, they adjust to whatever the braking system needed based on the dynamic conditions. So similarly, in a declarative policy model, your control system is just giving what is the end state, what is the desired state for the system, and your policy objects or your network objects take care of actually reaching that end state. Make sense? So then, another example of a declarative policy model used today is Kubernetes. Even Kubernetes says that if you want to have production deployments, you should use the declarative policy model for repetitive tasks. So any repetitive production kind of tasks, Kubernetes recommends the declarative policy model. And now let's go to the second concept of group-based policy model. So in a group-based policy model, what you have is pretty much you configure your application workloads, classify them into different kinds of groups, and you configure the policies on those specific groups. So for example, typically there are 3 steps that you would go about in doing this, right? The first step is you want to first go and configure or define what does a group mean. So as an example, you take an EC2 instance. Whenever you put a tag on that EC2 instance saying a web tag, automatically that EC2 instance will be classified into a web server group. Second step is you go and you tell what is the communication pattern between this group and some other group. So again, here as an example, you go and configure a rule which says allow only HTTPS traffic to be connected to my web server. So this group, whatever are the objects of that group, this policy will be automatically applied to those objects. And then the third thing you would do is render these policies dynamically. So again, what do I mean by that? Anytime a new EC2 instance comes up, identify what group it is part of and go and program the policies accordingly. So here, as an example, if you have configured this particular rule, allow HTTPS traffic, anytime the EC2 instance comes up, you would go and program the security group rule for that EC2 instance within AWS. So across the board, what's happening? Classify your application tiers into groups. Now those workloads can be of any types. Actually, in on-prem data centers, you can have containerized workloads, you can have like bare metal workloads, or you can have VM workloads. Again, in your cloud sites, you can have EC2 instances, you can have your containerized instances, it doesn't matter. So you're classifying your workloads into groups, you're putting in, configuring the policies on the group, and then as the workloads are dynamically spinning up, those policies are being rendered across the board, across the group. Now again, the two things, the declarative policy and the group-based policy, can be used to define what we call as a universal policy model. And again, how many of you are international travelers? Few of you. Imagine going to a country where English is not spoken. You need to have some kind of a translator, you need to have some kind of a way to translate from your language to the other. But for majority of the part, your travel becomes easy because English has been accepted as a universal language, has been accepted as a language where you can communicate with everybody else within that country. Similarly, when you're using these policy constructs, you're defining a universal policy model, which then becomes the same. It becomes agnostic to what data center you're running, what cloud you're running. It becomes agnostic and is being considered as a single pane of glass or a single policy model for your multiple hybrid data centers. And so I want to now come back and talk about the key components of the solution. We have the Cisco Multiside Orchestrator, which is a policy orchestrator. And this orchestrator we have enabled for on-prem data centers since a while now. The same orchestration policy or the orchestration model we are carrying into the cloud world. So the Multiside Orchestrator acts as a single source of truth for your organization-wide policies. So you go and configure your policies saying that these are the sets of classification for my group, these are the communication patterns for my group, and the Multiside Orchestrator will render those policies. It will actually push those policies to whichever site you are asking it to push it to. So it can be an on-prem site or it can be a cloud site. Then the second component here is the cloud APIC. So if you look at the AWS side, there is a APIC, there is a cloud, and there is an APIC icon over there. So that is a native controller that we have built for the public cloud. And that controller is sitting basically on AWS as an ARMY image. And it runs in AWS and it does a few key functionalities. First and foremost, it acts as your policy translator. So it is translating the policies which are defined on the Multiside Orchestrator into the cloud native policy language. So as, again, a network admin, you don't have to go and do the translation manually. You don't have to go and understand all the nuances of the AWS or the cloud policy languages natively. The policy translation is being done in an automated fashion. Then the second thing is it automates the full life cycle of the cloud router. So we use the Cisco CSR 1000V as a cloud router in the solution. It automates the entire policy life cycle of the cloud routers. And then it is also going to automatically detect whatever are the new workloads that are coming up and classify them automatically into policy groups and render those policies. So all the concepts about the group-based policy model, they are being applied here by the Cloud APIC. And the other key thing is we have built this solution from the ground up using the cloud native APIs. So we are using all the native APIs that have been provided by AWS to build this particular solution. So let's do a double click on how it looks like. So the Cloud APIC can run in any region within AWS. We support both commercial regions as well as GovCloud. The translation that it is doing is from your policy language from Multiside Orchestrator to the cloud native policy language. Now, you can also run this solution without an on-prem data center. If you want to do like a cloud first or a cloud only model of deployment, the Cloud APIC will connect, which is sitting to the Cloud APIC which is sitting in the cloud can connect to the Multiside Orchestrator, which can sit either on-prem or on the cloud. So there's that connectivity, once you enable that, you can run it in a cloud-only deployment model as well. And then the CSR 1000V, it extends your tenancy from the on-prem data center into the cloud side. So if you want to extend your multi-tenancy or your network segments between the on-prem to the cloud side, the CSR is going to help in extending that tenancy into different hybrid model. This is the example, the framework for you to think about in terms of how you can map policies between your on-prem data centers to the cloud sites. Now, in this framework, any isolation that is happening through the tenant, so the tenant isolation is happening through the user accounts for your AWS environment. Your VRFs in the on-prem data centers, they get translated into a VPC on AWS. Your network segments become the VPC subnets within the AWS world. Any group policy that you would configure become the security group rules. So we have this framework that you can use no matter where you are deploying, which location of on-prem or which location of AWS that you're deploying on. You can use the same framework for doing this mapping between your on-prem and cloud site. And then a little bit more of how it is architected, how we are building the solution. Now, as I mentioned, the Cloud APIC CSR can run within any region. Within a region, you would carve out typically a shared services VPC, which is a VPC where you will host your infrastructure components. So the Cloud APIC and the CSR will be hosted on the infrastructure within the infrastructure VPC or the shared VPC. And then the CSR will be running at least in 2 availability zones. So you have an HA built out. And then you have typically options for your inter-VPC communication. So one of the options can be using a transit VPC model where you take your traffic from your user VPCs, build VGW connection to the CSR. So from the VGW of your user VPCs to the CSR, you are building a secure connection. And then you use the transit VPC model for communication. Or you can use the transit gateway. So the transit gateway is a native cloud router technology that AWS announced last year, and it has been in deployment again. So the transit gateway, again, for your inter-VPC communication, you would use a transit gateway. We would automate all the life cycle for your transit gateway also. And then for inter-region communication, again, AWS just during this reInvent announced inter-region transit gateway peering. So we are working as part of our roadmap with AWS to get that support as well. But then you can use either tunnels from the CSR to the TGW or CSR to CSR for your inter-region on-prem to different region communication. And as I mentioned, the Cloud APIC is available as an ARMY image on the AWS Marketplace. The CSR image, spinning up of the CSR image and doing the whole life cycle of the CSR is going to be automated by the Cloud APIC. So I'm now going to hand it over to Azim to talk about the use cases, all the use cases for the solution.
Thanks, Mayuri. So what I'm going to do is next is double click on some of these use cases and what are the top of the minds that we have seen. So common themes comes in the cloud journey is use VPN. So when we started shipping cloud ACI start of the year, that we have completely automated. We take care of all the cloud constructs automation of the VPN creation. We also give you a template that you can use it and you can copy paste on your on-premises and get end-to-end working. That's already shipping and consumed by a lot of customers. Now what we are doing, which is also will be available shortly, is how to automate direct connect. Because we heard loud and clear from a lot of customers, especially if you are doing multi-tenancy, direct connect automation becomes a core component. And how to get the visibility end-to-end when you are trying to troubleshoot end-to-end for any application interconnect. So what we thought about is, we looked all the steps and sequence of direct connect, and then we said, okay, where it makes perfect sense to do a complete end-to-end automation. So we looked at step 5 and 6. That makes much more sense because some of the layer 1 challenges is very hard, and we can just pray for it, right? So we said, okay, let's focus on things that is in control our destiny, and we can get this better. So we said, let's do creation of virtual interfaces and take care of all the in-caps and create the BGP sessions or layer 3 connectivity, and then make sure that we have full end-to-end sessions completely up and running. So let me walk you through. Common scenarios we have seen customers start with full redundant data centers on an on-premises site. So you might have one or more than one sites. You will connect with some sort of a core or IP network environment or IPN device. And then you want to go to a cloud journey where you will have one or more regions, right? So in this case, I have, just for example, we'll take like 4 regions because you might have 2 in US, East and West, and then you might have 2 in Europe or maybe in Asia Pacific. Now, what you really want to do you want to cross-connect end-to-end, full, highly available, and completely redundant. So you will create a direct connect gateway, and then you will cross-connect with end direct connect full completely to a different path. So we will take care of full life cycle in this case, end-to-end, from provisioning as well as monitoring. So that is one common theme that we learned. Now what we will get out of it, right? So we make sure that we give you full network isolation. We will also give you a policy segmentation, even if you're running multiple applications, multiple tenants, multiple admins in that cases. We will also give you a complete end-to-end policy and network automation, so you don't have to go and do each steps manual. That becomes scalable because in future, if you want to scale out to other regions and as well as connect to other data centers and co-location site becomes seamless for you. And then final, as Mary talked about, operations is one of the key pain points to adopt new architectures, new applications. We take care of that life cycle as well. So let me walk you through with the similar scenario with TGW. Now in TGW case, what we'll do is we'll take care of all the core components. So we will do the attachment, either it's VPC attachment, direct connect attachment, or VPN attachment. We will do the association as well, and we will take care of propagation to make sure that all routes are completely in sync in that case. So once we have done that creations and propagations, we will also do the direct connect gateway cross-connected to on-premises in this case. Now there are multiple options. Like any architecture, you're defining it, you always like to see what are your business requirements and how you want to consume those requirements. So of course, we have multiple options. What we see is the option 1, which people generally using for complete shared services architecture. So let's say I have a scenario where I have all this shared by the same infrastructure. So I might want to deploy multi-tenancy, but I want to deploy at the end site with the same routed network. We call in ACI as L3 out. It's because it's a routed network. So you want to converge all this cross-connect to a same fabric. Now in this case, you don't want to burn too many ports, so you can even use the same port with multiple in-caps and multiple peering. So if you want to go with that route, you can have all this connected through an IPN network, and that IPN network connects to a spine. That is option 1. Now the option 2 is you want to have a dedicated connections, which is very common in enterprise because you might have DMZ versus non-DMZ or other compliance requirement. And you also don't want us to be an inline, right? Because in some cases, you're saying it, okay, I'm the network admin. I like you to do automation, but I also don't want you to be in the path. I want you to be completely help me in automation and visibility, but I want to have TGW directly connected with direct gateway and connect to a direct connect at the end and make completely highly available. So in this case, you don't be in the forwarding plane, but you do automation and take my policy plane and security and compliance. So we also allow that option where you can connect the TGW, create the transit WIF, and then connect the direct connect gateway and provision end-to-end. Now in this case, if you want to go with that option, you can directly connect to a pair of border leaves, and you can have, again, routed network connected to pair of border leaf with per WRF. Now in this case, what really helps you can even use this to cross-charge. What we have learned from a lot of customers that sometimes they want to charge back internally to their department based on devices or based on port. So that will help them as well. So we support both models. Now let me take you to the third model, which we just got announced this week, is inter-region support for TGW as well. We have multiple options even in this case. You can even use the backbone, which would be one of the recommendations. Or if you want to use more for affinity base, that let's say I have two different data centers, one in the East Coast, one is West Coast, and I want to make sure that I want to use local affinity connectivity from both direct connects to individual path, and I want everything to be completely highly available, segmented, and completely distinct. So in this case, you can still create two different hubs from the cloud APIC perspective, and they cross-connect completely separate. And we can monitor them between the two hubs. So CSRs, in this case, which is our forwarding plane, will be talking to each other and will know that which path is available, and we will always do cross-connect. So we can even use Interregion. We can use even complete full mesh connectivity as well. So we support both options. So let me do a quick recap. What are the options that we think that customers can consume? So in a summary, you can have single AWS transit gateway support with either direct connect if you're using high-speed bandwidth, or you can use with VPN. We also support multiple AWS transit gateway within the same region. Even in this case, we will allow you to support overlapping addresses, because a lot of customers has merger and acquisitions or some sort of a migration cases, so they can't re-IP in the right time frame. So we support that as well with the scale. As well as we will support cross inter-region AWS transit for multiple regions as well. So we support all of them. So that takes care for all the network connectivity and automation. Now let me switch to the policy segmentation. As Mary talked about, that is one of the core components for application or DevOps folks. So what we have seen trend in the industry, when you are developing applications and you're trying to deploy applications, you want to keep two things in your mind. Either you want to be a fully fault tolerant and highly available, which people generally refer as active-active or active scalable as clusters. Either you use monolithic or microservice architecture application, doesn't matter to us. And the second use case is you use active standby and or active DR, because you want to use one leg all the time, the other leg is always available. And it could be regulated based on business, or could be related to based on application or performance requirement as well. We support both models. Now, how we will keep those policy always intact end-to-end? So what we came up, and this is already shipping because we did the same thing between on-premises to on-premises. We use a lot of customer consuming it, and we allow this to a cross-cloud neutral case in this case. So what we do is we will take care of on-premises deployment for the WRF. We will make sure that that equivalent creates in your cloud environment, so which becomes VPC as your networking shell. Then we will create the applications, so which is your compute resources. We will tag them on both sides. So in this case, we tag them in the web for on-premises. We tag them as a policy group or security group in the cloud environment. Then we get the second tier, or depending how many tiers you have, we get the next tier. And then we will allow the security group rule or the intercommunication rules between them. And now in this case, if somebody wants to make a change from any orchestrator, we become the single source of truth, and we can contain or override instantly, because we always watch for the events and audit logs what's happening. So this becomes very powerful for the customers who want to keep IT governance very strong. So that is one common segmentation case. Now let me take the another case. As Mary talked about the holiday season, this becomes a very common case, especially when you're doing on-demand application scaling or segmentation. So in this case, cloud busting is common, comes in our mind, because when you are given a project by your CXO, you say, okay, let me start that as the initial case, because I know I'm not going to disrupt my critical application. I'm going to use this for scaling purposes. If something happens, I still have my active tier always working, and I can switch the DNS to redirect to make sure everything works. So that is actually pretty easy for us, because everything is already running in your active data center. We have to take care of all the intent and the policy. Now what we'll do is we'll just stretch the same policy. So in this case, what we're doing it, we are taking your VRF from on-premises and mapping in the cloud with VPCs. So we will create the VPC, we'll take care of the lifecycle, we'll tag those, we'll create the routing, and we'll make sure that everything in those accounts is managed by us. And then we make sure that anything that gets changed, we auto-contain it. Now I will give you a very simple example, because this is actually very common in everybody's mind. Now let's say I want to create a single regular expressions where I want to make sure that even prod and pre-prod both sit in the same VPC, but I want to make sure that if my tags are wrong, you just contain them right away, should not allow any communication. We will take care of that as well. So this is where the value of the objects and policy model and segmentation brings up in the environment. Now, what we also like to do is take this to the next level. So far we did is network automation, we did the policy segmentation. Now let me take it to the services, because that's a very common in our minds, especially when you're trying to scale out and IT and security governance comes in the picture. So in the services case, we already did deliver an ACI from day one, 65+ ecosystem partner. We have worked with almost all the top partners in the world. So how we did it is we just create a service graph or service chain intent. So you tell us what is your intent that you want to build. I want a front end with a load balancing, then I want a back end, in between I want a firewall. You define the intent, and then we render the intent and deploy it. Now you do it one physical site, or you do in one region, or you do a multiple region, doesn't matter to us. And not only we will orchestrate it, we will manage the lifecycle to get even the stats and other construct, which we'll talk in the next slides, how we will maintain and help you even in an operational lifecycle. So this is very interesting that we see a lot of customers asking. Now, let me take it to the next level is, what about shared services, right? I might have Active Directory, DNS, and other environment, because I'm adding more and more to get it more complex, to make sure that I have all the pros and cons combinations taken care. So I define the same thing. I can do another intent, and I define it, and then I provision it to whatever location I want. So in this case, I can have third-party services including. So I can have Palo Alto Firewall, I can have F5 load balancer, or anything that you want to define. So we will provision it, we will manage all of this in that. Now with that, let me introduce you to the ingress routing that got announced also this week. So what is ingress routing? In AWS VPC, this is an enhancement that allows you to give you a specific routing function within the VPC to allow to and from traffic from internet gateway, from VPC, or to allow to go even to a third-party devices. Now that gives you the quality that you can introduce any third party in between the traffic. Now commonly two use cases comes in mind. One is any traffic coming from north-south from internet, and you want to make sure that your security infosec or governance is allowing you to make sure that goes through a secure firewall. So you want to make sure that redirect to firewall first before it hits the application or the instance. So we will take care of that. Second use case is you want within the same VPC different subnets, and you want to redirect each subnet to different tiers of services. I can put first tier maybe to firewall, second tier to an IPS, IDS, or third tier I could be a load balancer. So you can do any combination. So with that, let me switch gear quickly to a demo. So this is my Multicenter Orchestrator screen where I define the intent. I have two-tier web and database, and I defined a service chain, which is pretty straightforward. You can just drag and drop and define that, okay, front end, and a firewall, which is in this case, I have a Palo Alto firewall, and I have a load balancer, which is I'm using NLB, and I have a backend. So let me double click on it, and I see a VM instance of Palo Alto firewall, ME images there, and then I have a VPC that we have created and manage it. Now what we'll do it, we create a specific routing rule in this scenario. So I have done this specific routing rule. Now to make sure ingress routing, I have to associate this routing rule to the right VPC that I want to enable those. And then I can automatically get the traffic taken care. So that is pretty powerful in this case. Now let me talk to you about how we can take this journey to an end-to-end hybrid cloud, because that is something top of our minds that we want to see that how smooth it will become in that case. So let me give you a complete end-to-end walk. So this is a multi-site orchestrator that we have shipping for quite a few years now. And the goal of the multi-site orchestrator, as Myri talked about, is becomes a universal policy orchestrator. So once I log in, I have an on-premises site, which is San Francisco data center, and I have an AWS site, which is US East. And you can see the schema and template, which is nothing, just a JSON XML file. So that creates the policy. And I can reuse any policy. I have multiple options. I can have the policy that I can extend to any regions or any site on premises, or I can add any new policies and keep it separate. So in this case, I just want to extend it in an essence of time. So let me go first and try to even register a new site, just to give you an idea how quick it is. So just registration is straightforward. You go to a marketplace, you download Cloud Epic. We will take care of all the bring up of the sequence using CFT, which is Cloud Formation Template. Once you have that is up and running, what we'll do it, we will get an elastic IP address from AWS. And that IP you use to just register. And you will give your admin login name and password. Once I have done it, boom, it registers. And if once it registers, we will start polling information, which is all the valid statistics that is up and running. I don't see any issues, any logs related. So I will make sure that it's green, completely interconnected. Now, once I have up and running, we will ask you a basic set of wizard, depending if you're using VPN versus direct connect, what automation you want. And once you have given that information, we will set up the underlay and overlay on top of it. So let me go to the policy first. So here I'm going to reuse a hybrid application policy, where I have two-tier applications. And I have two policy groups defined with a security group rule in this case. And I also have a service chain. Now here, if you see, I have 3-node service chain. And the reason I want to show 3-node is I can add any combination. I can use cloud native. In this case, I'm using ALB. And I can have third-party combination of that. And I can use the same intent to redirect any type of traffic. So let me go and provision this policy. So first of all, if you are trying to provision the existing policy, the multi-site orchestrator will prompt you that whatever is green is already provisioned. You don't need to worry about it. If you want to do new, you just checkbox the new site. And it shows gray because not deployed. Once I say it's deploy, it will go and provision it. Once it provision, it has a concept of a consistency validator. So it will go and verify it. Once it verifies, it will add in the dashboard that there are 2 AWS sites. So now you can see I have 2 different cloud epics within AWS. One I could use for prod, one I could be pre-prod. So I can have any combinations. And my schema, which was already for 2 sites, got extended in the 3rd site.
But Azim, the cloud epic can also manage multiple regions.
Oh, definitely, for sure. So very valid point, Myri. So in this case, if you want one cloud epic to manage multiple regions, we support that as well. So let me launch Cloud Epic directly from the multi-site orchestrator. The first thing you see is we tell you all the resources that we manage from the Cloud Epic perspective. And that gives you enough visibility at least to know what resources are created, rather than you go in different pain points and look for it. We also give you the full resources for on-premises that you have extended. Because in this case, I extended the same schema, which was already running in on-premises in hybrid cloud. So I see both sides of the house. Now let me zoom into the policy to see what the policy look like from statistical perspective. Is there any issue or not? I don't see it. It looks very healthy. Let me zoom into a logical view of the policy. So here you can see I have a web policy group and I have a database policy group. In between, I have a security group rule, which we call it contract. And I have a service graph, which is my chain, which I can add with cloud native as well as with third party. So in this case, I have chained already, which we talked about, the 3-node graph. Now I switch back to the AWS Console. So once I go to the console, I can see everything is done behind the scene for you. So as Mary talked about the universal policy orchestrator or universal language, that is what we are taking in this case. So here I have provisioned in US East the front end. I have done all the tags and VPC creations. I can even see the ALB creation where I define all the listeners and target groups. So I can see that's listening to port 80, and I have defined the target group with the particular IP address that I'm using it. Now let me go back to Multicenter Orchestrator. Now this is where it becomes very important to understand. We all know that deploying a new architecture or deploying a new application or new services is always very painful once you want to monitor for the whole life cycle for operation. So we want to make sure that it's not about that we give you provisioning and walk away. We want to make sure that we provision it, and we also monitor end-to-end. So let me go and explain you what we do in this case. So we have a concept of network insight. So network insight is our application architecture which manages all the operation life cycle. So we allow you to proactively monitor all the troubleshooting as well as resources. So we give you advisory information by telling you which information that you need to call, tag, end of life, end of support, all this thing, as well as we give you a full resource life cycle. What resource are you consuming on premises versus in the cloud? So I've launched my network insight resources. I can zoom in just to make sure it becomes easier. And I can see all the sites that is registered by the Multiside Orchestrator. I can select any of the site to see the specific resource. And then I can see all the anomaly detections in this case. So how we are running this anomaly, here we are running a bunch of different algorithms where we are trying to find out if we see any correlation between on-premises and in the cloud. We pinpoint by giving you anomaly score, and then we tell you exactly where the problem is. We'll always try to give you the best options, not only to find the problem, as well as remediate the problem. And that is where its value prop is. So let's go and see what these two critical problems are. So I can zoom into one of this, and I see there is some packet drop happening on one of the interface in a San Francisco data center on leaf 1. So that doesn't give me enough information what is exactly is impacting. Yeah, there's a drop, but is it impacting application in the cloud? Is the application only on premises? What exact is the issue? Let me double click it. Now I see a full end-to-end view. So it tells me on the right side that this is my on-premises site, and this is a path for that particular application in the flow. And on the left side tells me all the application flow for that particular path in the cloud. I can easily pinpoint in which application, which account, which tenant got impacted, and how. Also, I can zoom in and see the different types of trend, like what is the latency and what is the different types of information. Or I can click on the bubble where see red dot where the problem is. It will tell me exactly all the details, including the 5-tuple information that you need for your troubleshooting. Or if you want, you can capture the packet capture as well. So all these on-demand information is there. So that actually helps you enable your IT operations to at least pinpoint the problem rather than going between different teams. So this is one of the core value props for us to watch end-to-end operations between the two environments. With that, I will give back to Mayuri, so at least we can see what other things that we are working.
Thanks, Azim. So one topic I want to touch base upon is that of container networking. It's a hot topic. A lot of customers adopting container workloads, using applications, building applications using container workloads. But there are some problems as a network admin when you are building these applications. Problems is that around visibility, and it's that around operations. So when I say visibility, anytime your application teams are spinning up these container workloads, you need to be enabled to see what are the IP addresses, what are the typical communication patterns between these containers. Now with our on-prem data centers, we have integration with all the major container orchestration platforms today. Same integrations we are enabling for the cloud solution. Now what do these integrations do? The use cases that we solve is visibility. So on the APIC controller or on the cloud APIC, there will be a handshake between your OpenShift or your Kubernetes, upstream Kubernetes policies. We will provide you the visibility of all the container IP addresses, what are the hosts on which the containers are running, what are the host IP addresses on which these containers are running. So a lot of visibility is being enabled by these integrations. We also have the ACI CNI plugin, which we use in the on-prem data centers for your Kubernetes workloads. Or we have it again for Kubernetes, OpenShift, Pivotal Cloud Foundry across the board. So similar CNI plugin, if you are using upstream Kubernetes or if you are using OpenShift on cloud, we will enable the ACI CNI plugin. Or if you are using EKS, we will integrate with the native CNI plugin and then basically have that policy level handshake. So you can pretty much implement your container or the cloud native policy through the Kubernetes policy language, or you can use the ACI policy language to go and program the policies for these containers. Again, troubleshooting and visibility becomes easy because at this point you know what are the different networking components for your containers and what are the different communication patterns for your containers. So these are some of the problems which we are working on and which we are building as part of our cloud solution. Again, I want to stress a little bit on the day 2 operations. And pretty much, if you think about it, on-prem data centers, you have your logs, you have your events, and all the various information that you get from your hardware switches. In the on-prem data center, all of this information we consolidate on our on-premises SDN controller called the APIC. And similar consolidation of all the logs, of all the CloudWatch logs, the Cloud Trail logs within AWS world will be done by the Cloud APIC. So through the Cloud APIC, again, you get an operations pane view of what are the key consolidated logs within your cloud environment. And then on the Multiside Orchestrator, you will get the view of between the two worlds, the hybrid cloud view, which Azim talked about in terms of your troubleshooting use cases. You get all the different health information about what is the connectivity health between your various cloud and on-prem sites. You get all of that information. Now, as part of the vision, what we are working on is making assurance and intent validation enabled for your hybrid cloud workloads. Now, this is a very heavy term, but we have achieved this in the on-prem data centers today. So we have an assurance engine where we can actually assure that whatever configuration you have done, any intent that you have, we make sure that all of that is being enabled and it is adhered to. So similar vision we have for the hybrid cloud environments where you can have your intent validation and assurance in an end-to-end manner. And then, as Azim mentioned, ecosystem. It's very important for us. We have more than 65 ecosystem partners enabled for our on-prem data centers. The same ecosystem partners we are again bringing into the cloud with our cloud solution. Any automation tool you have, typically Terraform is the most popular automation tool which is used for the cloud. So if you have your IT ops team or your DevOps team who use Terraform for all the configuration, we have the Cloud APIC, Cloud ACI, SDK modules already available on Terraform. So you can use the same Terraform modules to go and program or configure rules for the Cloud APIC. We also have Ansible enabled. So you can use Ansible to configure the Multiside Orchestrator, or you can use Ansible to configure the Cloud APIC. And then ServiceNow and Splunk are two partners who have already gone ahead and enabled this integration for the Cloud APIC. So what the integration is doing is for ServiceNow, there is an ITSM. It's basically an ITSM platform which provides you all the visibility. It gives you a CMDB visibility, and it will also give you all the workflow information. So all the configuration that you would enable on the Cloud APIC, you will be able to see it on your ServiceNow platform. Similarly, Splunk has monitoring use cases. Any monitoring from your on-prem as well as cloud sites are being consolidated on the Splunk, and it will be given by the Splunk app. Now, both these ServiceNow and Splunk are available as apps in their respective app centers, and there is an on-prem version and there is a cloud version for these apps. Now, as some key takeaways, I want to stress upon these. The very first thing is you need to automate, simplify your connectivity. So the cloud ACI solution for hybrid cloud environments, we do that. We provide consistent simplicity, consistent and automated policy in your hybrid cloud environment. We provide a common policy framework, so your organization-wide compliance and policies will be adhered to. We have obviously the common governance and security policies and simplified operations. So across the board, any hybrid cloud, any hybrid networking related problems that you have, the solution provides a way to resolve those problems. These are some of the references which are available online, and then some related breakout sessions. We are also available to talk in our booth and one-on-one meetings. So with that, I thank you all for your time, and thanks for your patience.
Thank you.